So with the half reaction method in basic solution, okay, it's going to be very, very similar. We're going to balance it as if it's in acidic solution. Okay, so we're going to have some hydrogen ions floating around. But obviously, to be a base, you can't have hydrogen ions floating around because that makes it an acid. How does one neutralize an acid? By adding base, and by adding hydroxide. So that's how we're going to shift over to the base thing. So what I'm going to have you guys do is give you another one to try, and then I'm going to have you do it up to the point that you're going to add the acid. So, just out of curiosity, does anyone remember the name of that ion? You don't have to know it, I'm just asking. Say this again? It is dichromate. And it's in base, or it's basic solution, so there's going to be some, as we said earlier, some hydroxide ion. So what I would like you guys to do is get to step 5. Okay, like I said, this is going to be exactly as if you were working in an acidic solution up until that point. Okay, so you get very far? Oh, let me see. 14. You guys go +6 here? +2, +3, +5. That all look good? Okay. So oxidation occurred with the nitrogen. And again, it doesn't matter. You know what? Let's do reduction just to show you that it doesn't matter. Let's do the reduction first. So the chromium reduced from +6 to +3. Well, that helped. And the nitrogen oxidized from +2 to +5. Okay. Let me see, chromium, we're going to have, that's the first time we've had to do that. Everyone make sure they did that? I think that's the first time, isn't it? Okay, so there's that. We have to add 7 waters, 14 hydrogens. Okay, over here the nitrogens work out. We need to add 2 waters and 4 hydrogen ions. Everyone hunky-dory? Okay, now, that's where I had you stop. But like we just got done saying before we started this one, since we're in basic solution, we can't have a bunch of extra hydrogen ions floating around. We're going to have to neutralize that with hydroxide ion. The way we're going to do that is we're going to add enough hydroxide ion to neutralize the free hydrogen ions. So in this case, we're going to add 14 hydroxides. So now we have a neutral solution. But we're doing this in basic solution. So this goes back to the old algebra thing. Whatever you do to one side of the equation, you have to do to the other side of the equation. And so there's the key to this one, is numbers 6 and 7 here. We're going to neutralize the hydrogen ion by adding the proton hydroxide to each side of the equation. Same thing down here. We're going to add 4 hydroxides to neutralize that acid. We also need to add 4 hydroxides to this side. Now, the only thing this does, that's the only thing that's different than what we've done so far. Now we have to equalize the electron transfer just like before. What's the net charge on this side here? It is -2. And what's the net charge on this side? It is -8. Very good. 14 negatives, 6 positives. Okay? So we're going to have to add 6 electrons where? To the reactant side. Over here, what's my net charge? Pretty easy. -4. Over here it is -1, because these cancel each other out, right? So we need to add 3 electrons over here. We have to equalize electron transfer, so what are we going to have to do that? Multiply the top by the bottom by, how about we just do the bottom by 2, right? That makes sure that my electrons have canceled out. You guys agree? Okay. Now what? Combined terms. This gets a little uglier. And the only reason I'm saying that is this. What do we have here? Water. What do we have here? Water. What do we have here? Water. And what do we have here? Water. Okay? Who is that? Dang, what's the poem? Rhyme of the Ancient Mariner? You guys ever do Rhyme of the Ancient Mariner? Water, water everywhere, but not a drop to drink. You guys ever? Okay, no idea what I'm talking about. All right, something I've written in like 1498 or something like that. Anyway, there's water everywhere. When we combine all the terms, we want to have a net number of water molecules at the end. We also have hydroxide here. We also have hydroxide here. Once again, we want to have a net number of hydroxides. So we're going to have to cancel some things out and combine species. Following? Ready, set, go. Add them all up. What is the final equation? I'll give you guys an opportunity to do this on your own. Sure. How are you doing today? Done?
How do you like, you said there's something with the,
Okay, what I would do is find out how many water molecules there are on the reactant side, how many water molecules are there on the product side, and cancel like amounts. So for
if I
example,
like, oh yeah,
there's 19 waters over here and 8 waters over here. I have a net 11 waters over here.
okay.
Same thing with the
You can do that.
hydroxides. Yep. Like if you're solving for x, you don't leave x's on both sides of the equation. Same kind of idea. Done, Ashton? What's that? Oh. You might be done, but you're not finished.
Yeah.
Interestingly enough, I've seen this as not this particular reaction, but I've seen reactions like this, questions like this on the AP exam, where the question is, what is the coefficient in front of the chromium-3 ion? So they'll give you the beginning of the equation, and then the question is, what is the coefficient in front of the chromium-3 ion? Obviously, in order to find that, you have to do this. Hi, Mr. Homan. They're loving balancing redox reactions with the half reaction method in basic solution. They're flat out loving it.
It's the Gumshoe degree.
It is the Gumption degree. So let me see, what is the Gumption degree? Out of 1 to 10, what's the Gumption degree here?
And like 4.
They're not even sure what the word gumption is, Mr. Homan.
4. That's what
What's gumption, Colin?
But
What's gumption?
degree or something?
Ah, no.
Oh, okay.
Good try though.
You're ambitious.
Ah, what's that?
Ambitious?
Closer, closer.
What'd she say?
She said ambition.
Enthusiasm?
I don't know if you necessarily need to be enthusiastic if you have gumption.
Determination?
There you go. Now we're getting there. Finding a way. Don't give up. Make it happen. All right. Well, just for fun, I'm going to use blue for the waters. This ends up being, what, 8 waters here? Would you guys agree? 4 times 2? Okay. Over here we have 14 more water. I think I have all my water well, this is 4 waters. Okay, so how many waters currently on the reactant side? 4 plus 14 is 18 waters over here. Over here we have 7 plus 8, so 15 waters. So we have a net of 3 waters over here. Okay, so my waters are now gone. All right, what's the next species that's kind of a pain? The hydroxides? Here I have how many hydroxides? 8. Over here I have 14 for a net. 6 hydroxides on the product side. And everything else you just do. So let's go dichromate, 2 chromiums. We have 2 NOs. We have 2 NO3s. I think I've accounted for everything. Did that account for everything? Looks like it. Let's make sure our atoms balance. Got 2 nitrogens here, 2 nitrogens there. 2 chromiums, 2 chromiums. 2 plus 7, 9 plus 3, 12 oxygens. We have 6 oxygens here, another 6 there for 12 oxygens. 6 hydrogens, 6 hydrogens. All our atoms balance. Does our charge balance? Well, I've got 2 negative charges here. I have a net of 6, 8, 6, 2 negative charges over here. You guys agree? You can't screw it up. I mean, you just follow the plan. You can't screw it up. Okay, so where are you guys going to screw it up? Where are the little places to watch out for? What's that?
Oxygen.
Oxygens and hydrogens? In the sense of what?
Making sure you can account for them.
Well, okay, just keeping track of all your oxygen and hydrogens. Okay, that's one place. A lot of times students will forget to distribute here. Sometimes people will forget to combine the hydroxides and the hydrogen and you know, create water out of those. Okay, there's a number of little places that you can screw it up, but you really can't screw it up if you do everything correctly. Okay. I think you guys need to try one on your own. What do you think? Good answer. All right, here we go. So just out of curiosity, which method do you prefer? The oxidation states method or the half reaction method so far? Oxidation states, why is that? You like the half reaction method?
I would understand the oxidation state.
Yeah.
Ah, that requires practice.
This one
I'll give you plenty. Well, because it's,
Yeah.
but what does this do? It takes a
long.
huge amount of time,
Yeah.
okay? And so what we'll do is we'll go back and balance both of these equations and the oxidation states and just show you how fast that is. All right, so anyway, the one I want you guys to try this time since you guys love this stuff so much. Okay, there it is. Basic solution, balance this equation. Who just came in? Alex and this is actually half of the one we did yesterday, acid solution, basic solution. Here's the difference. In the acid solution, or the basic solution, everything's exactly the same when you get to heat. Now, in the basic solution, we can't have any extra hydrogen in there, right? So, we're going to add the appropriate amount of hydroxide to neutralize the acid, but we're going to also need some base in there, so we're going to have the hydroxide to both sides of the equation. So this is the only difference right there. Did you catch any of that?
Yeah.
Okay.
So you said that,
This would be it.
This big.
This would be it.
I don't know.
What's the name of that?
Okay, it's here.
See, as soon as you do that, oh, that's it.
Okay.
Yes.
I think I remember you saying that we don't. I open hydrogen here. Does it sound like the other side of the math plus?
Oh, you guys got to remind me of something. No, no, what do you mean?
Like put the hydrogen right here, does that make sense? Wait, we have to use a half there. Instead of B plus H2,
I would
right?
like you to use the half reaction method so that you
I said
learn
that
this.
once in practice, or the first one.
Yeah, I
Does that
know.
be,
We'll get to that.
that'd be plus H2 on this side?
No, you're skipping 5 steps.
No,
You just,
but I-
seriously, you just skip like at
So
least
they're just-
5, possibly 8 steps.
So we,
So here's what you do. I know that. You do this. So you
This-
determine the oxidation, so you determine the oxidation number of each species. Here's acid.
I'll,
I think that would be step 1. See, what you did is skip down to 5.
I was thinking that.
I know that you were thinking that. Don't do it. You did it, didn't you?
It's just that there's hydrogen.
I understand that there's hydrogen there. You can't screw it up, Ashley, unless you screw it up. That's the whole rule of AP chemistry. You can't screw it up unless you screw it up. You didn't skip 1 step, you skipped 5.
I was trying to.
Is this a redox reaction? Maybe I squeezed one in on you that's not a redox. Now Grace is wondering.
It
Okay. That's where you're stuck. Yep. I'll be right there. Who was that? Done?
Yeah.
That's a lot of work, isn't it? Following all that? You should see me try to grade this crap. Oh my gosh.
Yeah,
That's why I like the multiple choice question. What's the coefficient on
So does that mean all the quizzes test for people?
No, I'm actually gonna-
Right, and then got that one little problem.
I know, you'd be screwed, wouldn't you? So don't screw it up.
Oh, here's the individual one, like the coefficient one.
Like all the like signal it's like what's the one of them?
Jama, on a in the know theoretical math question where they say, if this is this, and this is this, and blah, 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 what's the answer? Almost always 1, or 0, but usually 1. You know what I'm talking about? Those really long questions they ask? Okay. So just, yeah, you can. So just like those questions in the know are always 1, I always know what James' answer to my questions are going to be.
Okay.
Sure. All right, moving on. Yo, go. Don't even, you guys, you're just go. I mean, you're gonna go off and you're gonna go down to the skate park and stuff. Is that what you're gonna do when you leave? No, the reason I say that actually happened one time. But anyway, moving on. No, it did. I'll tell you that story sometime. It was hilarious. Moving on. Hydrogen. Oxidation number. Everyone together now. 1 plus. Each. Therefore, each of these oxygens is 1 minus, or make minus 1 each. Oxygens here, minus 2 each. Chlorine, plus 7 each. Oxygens here, minus 2 each. Chlorine, plus 3. Oxygen here is 0. Everyone hunky-dory. Okay? So, writing these up, just for fun, I'll put the H2O2 here, and I guess O2 is the only thing I can do over here. Would you guys agree? Okay, what am I going to have to do at this point? Add water. Why do I have to add water?
Oh wait, I'm just kidding. Don't do that.
Okay, because my oxygen's balanced, right? So I don't have to add water. But I do have to balance the hydrogens by adding hydrogen ions. So we're going to put 2 hydrogen ions over here. But we're in basic solution, so we can't have a bunch of free hydrogen ions floating around. So now we're going to add some hydroxides. We're going to add 2 hydroxides. And if I add 2 hydroxides to that side, I have to add 2 hydroxides to this side. Boom. Electrons. Got a negative 2 over here. Over here we have a 0, so we're going to have to add 2 electrons over here. Okay. The other side. The other half. Okay. Chlorines. Are they balanced? No. So we're going to have to put a 2 here. Oxygens, are they balanced? No, we have 7 here, we have 4 over there, so we need 3 waters. Hydrogens are not balanced, so we need 6 hydrogen ions. We need to neutralize those 6 hydrogen ions by adding 6 hydroxides. And if we add 6 hydroxides there, we need to add 6 hydroxides here. Now we can balance the charge. Over here is neutral. Over here we have 8 negative charges. Would you all agree? So that means we need to add 8 electrons here. So far, so good? Now what? Yeah, we have to equalize the electron transfer by multiplying this by 4. Now we just add everything up. I combine like terms as much as possible. The waters are the main things, so we have 6 water here. We have 8 water here. My electrons, as you know, are gone. We did that on purpose. Hydroxides. We have 4 hydroxides. Sorry about that, I lied. 8 hydroxides here. And we have 6 hydroxides here. So far, so good? Doesn't matter what you start with. I'm just going to get the waters out of the way. I have 6 waters on this side of the equation. I have 8 waters on that. Oh, 11 waters on this side of the equation. Would you agree? 6 here, 11 here for a net of 5 waters over here. I get rid of those. Hydroxides, might as well do them. It looks like I have 8 hydroxides on this side, 6 on this side for a net of 2 hydroxides over here. And now it's a matter of just adding everything else up. So we get 4 H2O2s. Might as well get rid of the oxygens. 4 oxygens. Looks like a Cl2O7 and 2 ClO chloride ions. And I think that takes care of everything. Now it's a matter of just making sure that the atoms balance and then the charges. 2 chlorines, 2 chlorines. 8, 10 hydrogens, 10 hydrogens. 7 plus 8 is 15, 17 oxygens. We have 5 here, plus 8, 13, plus 4, 17 oxygens. I did my hydrogens already, didn't I? Yeah, so I got all the atoms balanced. Does the charge balance? -2 on this side, -2 on that side. Anyone get it right? Precisely. You forgot what?
I forgot to like collect the voices.
Oh.
Like I wrote down 4 times.
Okay. You just forgot to bring it down.
Yeah.
So no one got it right.
You missed something at the beginning and the rest was all just.
Okay. Then let me ask the question differently. How many of you followed along really well when I didn't? Okay. It's not that you can't do it, you just haven't done it enough yet. That's the main thing. You guys agree? There was something I was going to throw at you yesterday and I forgot. This is a completely off the topic. Well, it's on the topic, but it's different. Does anybody know what's going to happen there? And your first guess is wrong. Anybody thinking H2 plus O2? Yeah, that guess is wrong. Which now we have to balance that, so we need to do 2 here and a 2 here. Is this a redox reaction? Colin was this, and then he went like this. So which one is it, Colin?
Yes,
Yes? How do you know this?
because oxygen and peroxide went from -1 to -2.
Right. So if you were to balance this using the half reaction method, what would be the reactant species for the oxidation half? Well, H2O2. What would be the reactant for the reduction half? H2O2. See where I'm going with that? This is what the reason I brought this up is I've seen this word show up on the AP exam. Not that you need to know what the word means, but what would happen is you guys would see the word and you'd go, ah, because you wouldn't know what it meant. You don't have to know what it means. They'll give you the information. They'll say balance this equation or something like that. You'll balance it, okay? But this is called disproportionation. And what that essentially means is the same species both oxidizes and reduces. You run into that once in a while. You don't have to memorize it. I just threw it at you, tuck it away way back here in your brain somewhere, so if that shows up on the AP exam somewhere, you don't go, ah! Because you would do that, wouldn't you?
Me?
A little bit.
Yeah.
Yeah. All right, moving on.